So, welcome to our webinar this afternoon, where we are going to introduce our Problem Solving Schools initiative. We must say a huge thank you to Trinity College here in Cambridge, who fund these webinars so they're free for you all to attend. My name is Liz.
And I'm Charlie.
And we are members of the NRICH team based in Cambridge in the UK. Now, as I said, the aim of this webinar is to introduce you to the Problem Solving Schools initiative, and we will be pointing you in the direction of everything you need to know in order to join. So, Charlie, as by way of a background to set the scene, let's talk a little bit about being a mathematician. So being a mathematician is more than just being fluent with ideas, fluent with procedures and perhaps methods, and having a good understanding. Those things are important, but also a mathematician will be asking questions, will be exploring mathematical ideas, perhaps will be reasoning. They will be curious about the mathematics that they're working on. They may not give up when faced with a challenge. And so all of those things are integral to problem solving, as well as understanding and fluency. So some of you may know, but NRICH has been offering tasks on our website for a long time now. And those rich mathematical tasks give students the opportunities to develop those thinking skills and to be able to develop the skills to work like a mathematician. Many of our tasks are what we would term low threshold, high ceiling. So they offer opportunities for all students to engage in problem solving. However, we've been gathering feedback from teachers for a while now, and it became obvious to us that having this huge bank of rich tasks is fantastic, but it's perhaps not quite enough. And many teachers were seeking our advice about how to use the tasks in the classroom, how best to incorporate them into the mathematics and teaching and learning in their schools. And that is why we developed and how the Problem Solving Schools initiative was born. So that's just to set up a little bit of background for you. What we'd like to do now, rather than go straight into some nitty-gritty, some details about the Problem Solving Schools initiative, we'd like to have a go at a mathematical task with you to give you a little bit of experience of what we've just said. Charlie, may I hand over to you and we can get going on some maths?
Yes, I think what you said captures the main philosophy, that we want our students to work like mathematicians and have the opportunity to work like mathematicians, but too many come to the classroom expecting just to be shown how to do everything and expect that their role is to imitate what the teacher does. And this is giving the wrong message to students. To work mathematically, they need to be prepared to make sense of things for themselves and to work on sort of non-routine, non-standard problems. Work on problems that they haven't seen before.
Exactly.
So I thought that perhaps I'd ask you, we'd work on rectangles.
Okay, good.
And I don't know whether you've mentioned, Liz, the participants who've been invited to take part today are both from primary and from secondary schools. So I will start with some questions that might be suitable for primary age students, but I will also suggest some questions that we might ask secondary age students. So bear with us. We've got a large audience to cater for, but I think our experience is it's quite interesting for primary teachers to know where students are heading with the knowledge that they are being introduced to in primary schools, to get a feel for what might be asked later. And likewise, secondary teachers find it interesting to know what might have come before. Okay, so can we switch to the visualizer so that we can see what's going on? So I'm going to scribble here. Let me line this up a bit.
Good.
Okay, so I'd like to assume that we're working with students who've been introduced to the idea of perimeter and area.
Okay.
And I'd like you to give me the side lengths of a rectangle that, just an imaginary rectangle.
An imaginary rectangle. Okay. 5 by 2. 5 and 2.
5 by 2. All right. So some people add 5 and 2 and they double it to work out the perimeter.
Yeah.
Because if you do the width and the length, you're halfway round. Some people like doubling the 5 and doubling the 2, adding. And whichever way you do it, you're going to get a perimeter of 14.
Yep.
And multiply the 5 by the 2 to get the area. And we're assuming we're working with students who have got strategies for working out the area and the perimeter. Okay. Now, in this case, Liz, you've given me a rectangle where the perimeter is larger than the area.
Yes.
Can you give me another rectangle where the perimeter is larger? So we appreciate we're using different units.
Yes.
So for perimeter, we're using length. Yeah. For area, we're using square units. But I'm interested in the numerical value of each.
We're not going to let that worry us now. Okay. So another one where the perimeter is greater than the area. Okay. What if I had a 3 by 4 rectangle? Would that work? So 3 by 4.
The perimeter is 14 again.
Okay. And this time the area is bigger than before, but it's 12, I think, isn't it? But still less than the perimeter.
Okay.
Okay.
So I could ask you to give me some more examples, but instead I'm going to ask participants to use the chat to suggest some more. I've noticed that Liz has used quite small numbers.
That was to make the arithmetic easier.
Yes. So primary school teachers carry on with small numbers. Secondary teachers, perhaps challenge yourself with the kind of questions you might ask your secondary students, which is, can they come up with rectangles with slightly larger numbers? We're going to look at the chat.
Yep.
And we're going to copy some of the. So challenge is, can we have some more rectangles where the perimeter is larger than the area?
Okay.
Couple of minutes. Somebody suggested 1 by 1, where the area is 1, and that's definitely smaller than the perimeter, which is 4. Nice.
Yep.
And there's also been a 6 by 1. Oh, I'm thinking that anything by 1.
Ooh. Are you generalizing already, Charlie?
6 and 6, 12, 13, oh, 14. Perimeter 14 is popular. So straight away, I'm beginning to wonder.
Yeah, you're noticing.
That something by 1 will always have a larger perimeter than the area. And I might already be asking students to explain why.
Yep.
And I would definitely expect secondary school students to be able to engage with a question like that.
Yes. Yeah.
So I'm not going to write any more ones. There's a 10 by 2 has been suggested.
Yeah.
And from what I know here, the area is going to be 2 10s.
Yep.
the perimeter is going to be 2 10s plus 2 2s. So I'm tempted to think that anything with times 2
is also
going to have a larger perimeter than the area.
Yeah.
So I'm trying to model throughout this the kind of conversations that we want our students to have,
Yeah.
and if they're not having it, how we might prompt.
That's right.
And I'm being curious.
Yeah.
Even I may know the answer to this, to the questions that I'm asking, but I'm wanting to model in front of the children. What's it?
Yeah.
So
No, it's important to say, Charlie, I think that, we are moving at a pace which is much faster than it might happen in the classroom, obviously, but we should say that.
we're very keen to finish this bit of the webinar by 4:30. So absolutely.
Yeah.
And what I like about Dell's suggestion, by putting 100 by 2, it's what Tim Rowland talks as generic example.
Right.
If it worked for 100 by 2,
Yeah.
we can sort of understand.
Yeah.
So 100 by 2 is going to be area of 2 100s.
Yep.
And the perimeter is going to be 100 plus 100, which is 2 100s, plus 2 plus 2.
Yeah.
So it's going to be more than. So that's really nice. It could be 1,000 by 2, and I could figure out.
Yeah.
Okay, brilliant.
Great. Okay.
How about
That's got
we
the
put
juices
this
flowing.
to one side?
Yeah.
Liz,
Yes.
could you think of a rectangle?
Yeah.
This time where the perimeter is smaller than the area.
Okay. Just when I was beginning to sort of get into my comfort zone. Right.
Absolutely.
Perimeter. This is good though. You're disrupting me, making me feel
It's getting too easy.
Yeah.
But
popping the challenge in. All right.
I mean, we might come back to this
Okay.
because we've done 1s and 2s and a 4. I mean, well, let's have a look at what happens.
Okay.
Do you want to give me one of these?
5 by 7. Is that going to work? So 5. For some reason, I always find it easier to work out the area first. I guess perhaps it's just the way that we're recording it. 5 by 7 is 35. And then
we're
we've
not
got
recording
2.
it that. Oh, I see. Right.
Sorry,
5
we're
by
writing that first.
Okay.
Yeah. And then 2 lots of 12 is how I would think about it.
5 and 7
So
is 12.
24
And 24 is
is the
indeed.
perimeter.
Okay.
And smaller than the area.
So can somebody help Liz with some
Some
more
more, please.
examples in the chat, please? And while you're doing that, an invitation to observe, notice. I want you working a lot more like scientists in a laboratory, gathering data and being always on the lookout for patterns and generalizations. There's a 6 by 4 suggested, where the area is 24.
And then 2 lots of 10. 20.
Yes. And there's a 7 by 7.
Okay, 49. Yeah. And then 28, I think.
4 7s are 28.
Yeah. Yeah.
Oh, and there's also an 8 by 8.
Okay.
If anybody notices anything
Pop
distinctive,
yes.
Courtney's put 10
10
by
by
10 and Dell's put 9 by 9 now.
Okay, so that's 64.
And 4 8's 32.
32, yeah. Square of a number. Joseph is questioning
So
what's significant then about this?
so that's interesting. And I presume, Joseph, I would push you if you were my student saying, oh, but we had a 1 by 1 in our previous example. So is it certain squares or most of the squares? All the squares? And 2 by 2 is quite interesting as well.
Yes, that is interesting, isn't it?
So Judy has put until 4 by 4. So
Judy's exploring 1 by 1, 2 by 2, 3 by 3.
we sort of know about the 2 by 2 because we came across that, but we hadn't done 3 by 3.
No, okay. So 3 by 3, we've got an area of 9. And a perimeter of 4 3 is
12.
Yeah. Okay.
And 4 by 4 doesn't fit onto either sheet.
No.
But after 4 by 4, Judy is suggesting that sort of 5 by 5, and that works because it's 25 and it's 20.
Yep.
And there is, again, some generalizability going on here. Do you notice anything about these shapes, Liz? These compared to these.
These feel sort of long rectangles. I think I kind of I think you can see my hands here. I'm doing a sort of a long narrow rectangle. These feel more like
a lot of perimeter is sort of fencing in.
That's a nice way of describing it.
A bit of area.
Yes.
Whereas
here we're tending to, well, obviously we've got some squares, but we're tending towards the square. We're packing it in.
Yes. Yes.
It feels intuitively right there. It's quite hard to use mathematical language to describe what we've noticed, but it feels intuitive, doesn't it?
Yeah. So I'm pretty sure that if we had two very large numbers here.
Yes, okay.
Like, I don't know, 40 and 50, for example. That would be an enormous area.
Yes.
I think it's 2,000.
Yeah.
But the perimeter is going to be much smaller, 180.
Yeah. Yeah.
Is it possible to have two big numbers and still have the perimeter smaller than the area?
Ooh, what do we think?
Can we leave that with everybody to think about?
So two big numbers, like big numbers, Charlie, over 100? What do you mean by big number?
Okay. Is it possible to have two numbers which are larger than 100, that are larger than 100?
But have the perimeter greater than the area?
Actually, I might just leave that hanging.
Mm-hmm.
Please remember, I'm asking these questions just to capture what Liz was talking about, low threshold, high ceiling tasks. Everybody can be working on rectangle at the same time.
Yes.
But there are a variety of thought-provoking, non-routine questions, some of which are more demanding than others. So we're not saying only our most talented, high-flying mathematicians are to be given thought-provoking questions. Everybody can be given thought-provoking questions, and the low threshold ones are less demanding than the high ceiling ones.
Yeah.
But all of them are require students to apply and adapt their knowledge.
Absolutely.
All right. Liz, we noticed that the perimeter could be equal to the area.
Oh yes, we had
a 4
by 4.
4 by 4.
Yeah.
16 and 16.
Yes.
Can we have on the chat any other rectangles? Notice that we're calling a square a very kind of special kind of rectangle. Are there any other rectangles where the perimeter is equal to the area?
This may be something you might have this kind of knowledge at your fingertips, but you may not, and that's okay. So you may be exploring, you may be trying things out, you may be using what we've just done to think about it, but it may be familiar to some of you already. But and that's okay.
Yeah. Yes. Yes, Ian has generalized in terms of half the area must be equal to length plus width.
Yes.
And again, okay, so some people may know that these are the only two which have got whole numbers. But again, I'm just going to suggest for secondary teachers, this is a really nice opportunity to maybe introduce a bit of algebra.
Yeah.
I can be saying, well, let's just imagine that we've got a rectangle where the length is 10. Is it possible to have a rectangle where the area and the width are the same and the length is 10? And so We don't know what the width is. We're going to call it x. And we know that the area is going to be 10 times x.
Yep.
And the perimeter is going to be 10 plus 10, 20, x plus x, 2x. And we can simplify this by taking 2x from both sides.
Yep.
8x equals 20. And so x equals 2.5. And so in this case, the area is 10 times 2.5, 25. And the perimeter is also 25.
25. Yeah.
And so can we find some more where it's not a whole number? Nice, really nice use of algebra, not too demanding.
No.
Lovely to connect a bit of number work, a bit of algebra, and a bit of geometry
Absolutely.
here.
Absolutely.
So a little nice excuse to do a bit of algebra. Now, Liz, so far I've been asking you to give me the length, and we've been working out area and perimeter.
Yes.
I want to do something different now. I want to give you the area and the perimeter.
Okay. Yes. Right.
And I want you to tell me what the side lengths are.
Okay.
And what's special about these 4 rectangles is that they've all got the same area.
Right. Well, knowing that they've all got the same area, I guess what I might do is think about, again, I'm coming to this relatively quickly. This is not necessarily the speed at which your children would, but I think I'm thinking factor pairs. I'm thinking, okay, so I want to 24. I might do, I know that 2, well, where shall I start? Shall I be
2 times 12, yes.
Okay, 2 times 12 is 24. So if I'm using side lengths of 2 and 12, then I've got 14, 28 perimeter. So I think that's this one.
2 times 12. So the factor pairs the product of the factor pairs will give you the area.
That's right.
Okay.
That's what I'm thinking. Would you like me to carry on? Should I try another one?
Yes, please.
Okay.
I want you to do them all.
Okay. Right. What about, I know that 3 8s are 24. 3 plus 8 is 11, so 22. So that's this one. Righto. You've written these. I'm just noticing now that you've written these in numerical order here, which I think I should have noticed because that's helping. Right. So
we put aside the word should.
Okay. Yeah.
Okay. There's no should about it. At some stage, you will notice.
Okay. Right. So 3 and 6. So what about 3 and 8? 4 and 6 multiply together to make 24, and I think that's the perimeter of 20. 4 and 6 is 10, so 2 of those, yeah. Okay, and then we've got one down here. So 1 by 24, and that gives us the perimeter of 50.
Now, can you go back to this idea that you had earlier about some rectangles being thin and long and some being...
Yes.
What do you notice here about these 2 rectangles, for example, as compared to these 2?
So I guess if I'm fixing the area, so here I've got my long thin rectangles have got I mean, looking at this one, a much larger perimeter than my nearer square shape rectangles is my sort of, I guess, my way of thinking about it.
Yeah, and the way I think about it is polar bears and snakes. And polar bears live in very cold climate, so they want as little of their surface exposed to the cold, so they're very square, and where snakes are a very hot climate, and they want to have as much opportunity to perspire, and so this is a snake. Right. If you were one of my secondary school students, I might then say, oh, well, another thing that I notice is the perimeter is always an even whole number.
Oh, yes.
And it looks like, oh, we could explain why, because I'm going to have width plus length. Sorry, I'm going to have, width plus length doubled.
Yes, and the minute you double,
you're
going to get an even number.
You're going to get an even number. So do you think it's possible to have a perimeter of 35 and an area of 24?
Oh, right.
Can you think about your snakes and polar bears?
Okay. So this is where maybe the numerical order you did here is quite handy, because I noticed that a perimeter of 35 comes between 28 and 50. So that makes me think, actually, my side length will be between 1 and 2. So 1.5 might be my starting point.
Okay.
So
So far, we've got 1.5 there.
Right.
And a perimeter of 35.
Okay. So I might think about, okay, what do I multiply 1.5 by to get an area of 24?
But that's hard.
It is quite hard. Yeah. Okay.
Let's think about the perimeter.
Half of 35. Oh no, I know. This and this make 3. So if I take 3 away from 35, I get 32. And then I want 32 to be these two lengths. So 32 divided by 2 is 16.
And we can check 1.5 times 16 is indeed 24. Okay, so we might have a conversation of this sort with students. And then my challenge might be to say to students, I'd like you to think of a rectangle, work out the area in the perimeter, tell your partner what the area in the perimeter is, and see if they can work out the side lengths.
Yes, nice.
So I'd like to invite you to do that in the chat. Now, I'd like primary school teachers who are teaching, say, Year 5 students to be solving the problems that other Year 5 teachers have said. So what I would really like you to do in the chat is say, for example, here's an example of what I might want my Year 5. So Year 5, perimeter and area, and then find another problem set by either Year 4 or Year 5 or Year 6 teachers. Whereas if you are a Year 9 teacher in the UK, so you're teaching sort of 13, 14-year-old students, you might set something slightly more challenging. So, write down which students you have in mind, the level of difficulty that you would want them to work on, write down the area and the perimeter. So please post something in the chat with the area and perimeter and your year group, and then have a go at solving the problem that somebody else has posted. Yes,
it might be, rather than put a year group, it might be handier just to give you the age, rough age of students, because I know we're from slightly different countries, aren't we? So maybe that makes it a bit clearer. So if you post an area and a perimeter, the rough age group that you would expect to be working on that rectangle, and then we can be looking to see if we can find the dimensions, the side lengths of that rectangle you've given us.
When I've done this with students, what's nice is that students really, really want to solve the problem that they've been given by their classmate. And they also want to make the problem that they give their classmate as challenging as possible. The students end up working on problems which are possibly much harder than the problems we would give them. And that is fantastic to see everybody willing to struggle and so pleased when they can overcome the challenge that they've been given. Thank you, Stephanie. And Rebecca. So we've got a suggestion for Year 5, which is for those of you who are not in the UK, I tend to just add 4 years to get the age of students.
Yeah.
So Stephanie is really challenging us. An area of 19.25 and a perimeter of 18. Wow. What's also quite nice is sometimes students make mistakes when they work out the area in the perimeter, and they might write something that's impossible, and they get instant feedback when somebody's made a mistake, which is nice. Oh, I also like this. My area is double my perimeter.
That's nice, Courtney.
Is there only
Yeah.
one
Yeah.
possibility or are there many possibilities? Yes. Or my area is two more than my perimeter would also be an interesting challenge. Right. It's 4:30
Yes.
and Liz and I, in our notes, said we were going to stop.
We need to canter on, I think.
I've got last question.
Yep.
I'm not going to give you anyone a chance to think about it during the session, but our question to finish off, or my question to finish off, is it possible to have a rectangle where the perimeter is a fraction and the area is a whole number, and vice versa? Can we have a whole number perimeter and a fractional area?
That's something to mull over.
Something to mull over. I'm sort of tempted to. I think the answer is yes to both. And my challenge to you is, can you find
one? Can you find an example?
Yes, because otherwise you might decide something is impossible. I'm pretty sure they're both possible. Okay.
Thank you, Charlie. So, we hope that has given you a little flavour by having that experience of being a problem solver yourselves. We hope that has given you a flavour of the way that we can weave together the mathematical thinking, so those things we were doing like exploring, noticing, beginning to conjecture, we can weave together those skills with the idea of becoming more curious, having the desire to keep going, not giving up, weaving all that together with our conceptual understanding and fluency. So the value of a task like that, Charlie, one of our low threshold, high ceiling tasks, it provides the opportunities to do all those things together, because we know teachers are under time pressure to get through the curriculum, as it were. So we wanted to give you that flavour.
Yeah, we don't want to see problem solving as separate from developing children's fluency and working out areas of perimeter, for example. It's all bundled together. We can do it all at the same time. They can work on area and perimeter while still being given engaging problems that they get some pleasure out of, and require them to think mathematically.
Exactly. So let's introduce you now to the nitty-gritty, if you like, of our Problem Solving Schools initiative. So what we have done is we have identified some key elements that we would encourage you and your colleagues at school, so it's a whole school, to encourage you to think about if you are wanting to raise the profile of problem solving in your school. Now, what we've done is we've pulled together these elements into what we've called our Problem Solving Schools Charter. Now, what I'm going to do is I'm just going to share the NRICH website, because we have arranged our charter into a number of statements. I think there are 22 statements altogether. And they are grouped under 5 headings, which I'm hoping you can see now.
Yes.
So the first heading is values and ethos. So this is thinking, as either a whole school, in the case of primary school, or a mathematics department in a secondary school. What are your beliefs about mathematics teaching and learning? Because if you take time to explore those and to tease those out as a community, then that is going to feed into the way that you lead your department or school in mathematics, and the professional development opportunities that you and your colleagues are provided with and that you prioritise. So in turn, the way that you lead the subject in school will affect the way you design your curriculum, the pedagogy surrounding mathematics teaching and learning, and the way that you assess children in mathematics in your school. And of course, all that feeds into the classroom culture, the everyday practice in the classroom, the environment in which students, children are learning mathematics. And we shouldn't forget that actually mathematics is more than what takes place in the classroom. So this is a chance, that final section of our charter is a chance for you to think about the problem solving that might take place beyond the immediate 4 walls of your classroom, or perhaps even beyond your school? Do the children in your school get any sense of that, of there being more to problem solving than maths lessons? What we'd like you to do is we're going to give you an opportunity now to, what we could do is pop the charter on the screen and invite you to read it. But we're going to do a little activity, which we've never tried before quite in this way, to help you engage with the charter, we hope.
So we've got 22 statements that we've written.
That's right.
Under each heading, there are either 4 or 5 statements.
Yeah, thank you for clarifying that, Charlie. Yeah.
And
so
we've muddled them up here.
We've muddled them up. So what you've got here is it's effectively like a card sorting exercise. You've got all 22 statements. Let me just scroll down for you to get a sense. What I have done, Charlie, to set this up is I've kind of dragged down one of the statements that were put at random in these sections, just to the bottom here, which gives us a bit of an opportunity to have it's given us a space in each category. So why don't we just start this process off and have a little read of this first statement here and decide which of those 5 categories it might go into. So this first one, we ensure that problems and classroom support offer opportunities for all to experience both struggle and success. Of our 5 categories, Charlie, so here are the 5 again. Well, which do you feel
it says ensure that problems should offer opportunity for all to experience both struggle and success. This feels like a curriculum-y decision.
Yeah, it feels more than just the classroom, I think, doesn't it? It has to be a sort of an all-encompassing thing. Okay, so what I would do then, oh dear, I'm going to take that and I'm going to scroll right up and I'm going to pop that in our curriculum section at the top here. So we've put one of those in, Charlie. Oh, so what I might do is give us a space and move this. So where do we think, oh, hang on. Where do we think this one might go? We regularly embed non-standard problem-solving opportunities in our maths curriculum for all learners.
I think that might be in the right place already.
I think we might have that in the right place already. Okay, so let's leave that there. So what about this one? We celebrate multiple approaches to solving problems and discuss the merits of the different strategies offered. Which of our 5 sections do we feel that? Just a quick reminder of the 5 sections.
That feels like a classroom culture.
That does feel at the classroom level, doesn't it? Okay, so let's take this down. Oh, look, we can take this down here. Shall we stop there?
Okay, do you want to
let me move one out of the way. Yeah, okay. What I'm going to do is in the chat, or have you already done it, Charlie? Brilliant, thank you. Charlie has posted the link to this interactive in the chat. We're going to give you a couple of minutes to glance over it. Perhaps you could suggest where you feel one of the statements, choose a statement, which section it might belong in. I'll put the sections back here. I'm posting the chat rather than typing out the whole statement. Just put the first 5 words or something because we'll be able to find it. So there are 5.
Put a link to the card sort rather than to the charter, so you get a slightly different muddled up version.
You will do, yes, because we've already played around with ours a bit, and it won't necessarily give the same starting point. It will randomly mix up the cards. So if you spot a statement that you think you can fairly comfortably put in one of our categories, do post in the chat, please. Have a little look.
Can you go back to the problem?
Yeah.
I'm just checking that we got the first 2 right there.
Oh, did we? Oh, good point, Julie. Yes, that hadn't occurred to me. Yes, very good point. Yeah.
Okay, so Kim has written something about a safe environment, going to classroom culture. I've got the actual charter in front of me.
So that's the one which says we create a safe environment which learners can explore, take risks. Yeah, we feel that would go in classroom culture. Yeah.
Well, and I've also checked it.
You've checked. Yeah, thank you, Kim. I won't move it, but yes,
Oh,
absolutely.
yes.
Oh, okay. I'm going to get into trouble. Oh, I keep pressing too hard here. Let me move this down. There we go. Here we go. So we're going to put that down there. Good. Just move this one out the way to give us a bit of a space. Okay. Oh, Courtney has suggested mathematical ability is not fixed to go in values and ethos.
That is indeed the right place.
Right.
Yes,
Oh, we can't find that statement. Oh, there we go. There it is. So that needs to go right at the top. Thank you, Courtney. I would agree. There we go. Let's move this out the way. No. Yes, have you, sorry, Charlie, have you got some?
Stephanie has written about engaging with printed
Oh, yes.
under leadership.
Can't find that one on my screen. Oh, here we go.
Printed online and face-to-face professional development opportunities offered by subject. Okay.
Yeah. Okay.
I think perhaps we should stop,
Yes.
but we were offering this in case you're wanting to work on the charter with colleagues. It gives you a chance of engaging with it in a more active way,
Right.
rather than just
putting something up on the screen.
reading it and forgetting about it the next minute.
Absolutely. So what we'll do now, let's show you what the charter does look like. So if I go to the home page of NRICH, and here's our problem solving schools menu, and you'll see that the third item down here is our charter. So here you have got the statements in inverted commas correct places.
And at
Sorry,
the bottom
Charlie.
of this page
Yes.
is a link to the interactivity.
What we've just been doing, the card sort, if you did want to use it again. So as if you decide to sign up for our Problem Solving Schools initiative, we'd be inviting you to look at the charter alongside your colleagues, either as a whole staff in a primary school or as the department in a secondary school, and to reflect on your current practice in terms of problem solving against these statements. Now, you will notice that some of them have got links, which is where we're offering you a bit more information to support you as you reflect, but also as you might work on these areas. What we would go on. Would you?
Yes, and it's still a bit thin in terms of the information and guidance, but it is something that we'll be working on in the next few months. We're aware that this could do with a bit more support.
Absolutely, exactly as we're working on. And as well as those links, some of the links in the charter, for example, this one about mathematical thinking and mindsets takes you to our current resources and PD page, which we are working on, as Charlie's intimated there, which will look a little bit different soon, where we have begun to populate with further resources. Here we've got links to recordings of webinars that we've done in the past, and guidance pages where we link to NRICH resources that particularly will help you think about developing any of our 5 mathematical thinking skills, or any of the 4 sort of nurturing these 4 mathematical mindsets that we have outlined on the website. Now, our latest development, which we're really excited about, is what we've called our Problem Solving Schools Hub. So if you choose to sign up to become a problem solving school, you will get access to our hub. And what I'm hoping that we can show you now, here we go. Charlie and I have logged in as a false school to give you a little bit of a sense of what this looks like. So this is where you would come. You would have the dashboard is the sort of the center of the hub. And you can see straight away that what we do in our hub, we offer announcements. So this is, as you can see, it might be about a webinar, it might be about collaboration opportunities, interesting mathematics that we've been thinking about. So here's a way to for us to share news with you as a problem-solving school. But we'd like to just show you as well that when you first sign up and you're being invited to reflect on your current provision using the charter, you would then we would be inviting you to submit that self-reflection via the hub. So if I just scroll down here very briefly to give you a sense, you can see that this is the first section of the charter, and we would be inviting you to think about currently in your school in terms of, is it evident to learners that mathematical ability is not fixed? Where do we sit here? Is that something that that we feel we really do embody in our school, or actually maybe that needs a bit of development work? So we would invite you to place yourself on the 5-point scale for each of the statements. The hub makes it really easy to save a draft of this, to come back to it. You can look at, we invite you to return to your self-evaluation after perhaps at the end of an academic year or the very start of the new one, and you can access all that really easily in your dashboard.
Yes, schools who've been participating for over a year can carry out the self-evaluation at the beginning of an academic year or at the end of an academic year and compare their responses in the present to what they did before. They can use that to monitor progress.
That's right. You've got, just very briefly as well, you've got a notes section. You could use that to kind of record some decisions that you've made, maybe what you're planning to do. Once you've submitted your self-evaluation, I invite you to identify 3 areas for development, which link to 3 areas, statements of the charter, roughly speaking. And so you might be using the notes area to document decisions made in staff meetings or department meetings, or thinking about plans going forward. So it's all there in your dashboard. In terms of the nitty-gritty of becoming a problem-solving school, you can see if you would like to join, all you need to do is click here. There's some basic information, hopefully, which we've made clear as well here. We wanted to just emphasize a few points that this is open for any school to take part in. You don't need to meet any standard, any initial criteria, any minimum standard, as it were. This is all about you reflecting on your practice. It is totally free of charge. I don't need to say any more than that. And you can sign up at any time in the school year. It doesn't have to be within a certain period. One of the things that we're really keen to emphasize is that self-evaluation process using the charter, we really encourage you to use that in a collaborative way with your colleagues. So we would prefer you, perhaps as the maths subject leader, not to go away and squirrel away and fill that in yourself. This is, we've deliberately termed this the Problem Solving School project. It's about bringing your colleagues with you. And I think we might have covered most of the points. If you are not at all familiar with NRICH, then it is worth saying that depending on the age group you teach, you can find relevant rich tasks, low threshold, high ceiling tasks that we were talking about by going to the teacher's landing page. If you're particularly interested in finding tasks because of their curriculum content, then choose the curriculum linked box here. And you may like to look at our curriculum mapping document where we've linked tasks, rich tasks, to curriculum statements. You may prefer to particularly choose a task because you wanted to work on developing your students' mathematical thinking. So then in that case, you might want to browse the collection of activities where we've organized them in that way here. Or it may be that you're wanting to nurture your students' mathematical mindsets, and so that is another way in to our tasks.
It's possibly worth mentioning, Liz, that if you go to either the primary or the secondary mapping documents, you can see the problems, and it is also possible to that happening?
There we go.
Yes. So here we've got problems according to topic, but you can then say
You can narrow it down. Yes,
you
sorry.
can narrow it
Good idea.
down. So I want problems that really demand explanations
Yes.
and reasoning
Yep.
and stuff.
Yep.
And these appear in
highlighted
bold.
Yep. Yep.
So you can, chances are most people are organizing what they're doing according to topics.
That's right.
But also when, well, let's stick to this. If I mean, I don't know these problems, but if I choose a problem that like less is more,
Yep.
it tells you here on the right-hand side
Yes.
that there's some explaining, convincing, and proving involved,
Yeah.
as well as curiosity, collaboration, being resourceful.
That's a great task. That's a great task.
Yeah, it's one of our favorites.
So well, I think we've reached the end of what we would like to say, what we've prepared to give you an overview. We hope that's given you a useful overview. We hope you will consider joining our Problem Solving Schools initiative. And of course, if you have any questions after today, then do go to the Contact Us button on NRICH, and your emails will find their way to us anyway. So thank you very much.